Let's find the area of this yellow piece. That will give us capital R. That depends on x. That is top minus the bottom case. Top minus the bottom case is axis of rotation. What's the name of that axis? Who remembers? It's over here. See? Y equals 36. That's the line of rotation. Y equals 36 minus, what's the bottom line equation? X. Y equals x. So we're going to do that. Then I will finally admit that there is a gap, and I will find the area of the gap. So let's do the first one. The first one is y equals 36 minus y equals x. Top minus the bottom. Why the square? Because pi r squared. Pi r squared. The second one may be a little bit more confusing, so let's do this one carefully. The second one, we're finding the radius as the area between graphs for this part, the gap. Again, you can find the radius for this part, they are the same. Just be careful with all the functions, but we don't know the graph, we don't know the equation for this function. Because we know the equation for the bottom function, then we're going to do that one. But because it's pi r squared and it's squared, negative sign will not matter in this case. So let's do the bottom one. How to find this distance? Only this white one. We only look for the white distance. Top minus the bottom. It still comes from the axis of rotation, which is y equals 36. And then minus what? 6 squared of x. 6 squared of x. Let me write it down here. Y equals 6 squared of x. And that is the second one. Top, which is y equals 36 minus y equals 6 squared of x. This is the most complicated part of this washer method. If you got disk method, this is the same, but just plus one more piece. However, let me maybe explain better over here. The shape was a triangle that is spinning. So we have a triangle and it spins, right? So an original one, so this is the whole piece. So I found the volume of the whole piece when there is no empty part inside. That's first pi r squared. And the second pi r squared actually recognizes that there is an empty piece inside of this tube. And we decide to find the volume of only part inside, the empty part. And we're subtracting total minus the empty. That gives you the difference. Does it make sense? I feel like I'm not an engineering in my mindset, and I still feel it like it makes sense. The whole thing minus empty thing gives you the difference. It gives you the whole thing with the gap inside. Pi r squared minus pi r squared. One more way to explain it, and I like explaining it this sometimes as well, is using the laser idea. If you're into Star Wars, I think you will enjoy it, but just check this out. Check this out. Maybe you will like this more. People have different ways to understand things, so I like showing several. To find the radius and pi r squared, every time you put the beginning of the laser in the center. This is center of rotation. And then you first shoot it to the very edge of the object. So I will put it somewhere here. Let me delete the previous one. And I shoot to the edge of the object. Find this area. It's top minus bottom or right minus left, depends on the case. But you put it in the middle axis of rotation and shoot the laser to the very edge. This is going to be your first R, capital R, capital R. There's going to be, in this case, 36 minus x. 36 minus x. Then another laser starts. Put it again somewhere in the axis of rotation. And now you shoot not to the very edge. You shoot to the end of the empty part or to the middle edge. So there are two edges of the 3D object. There's an outside edge and there's an inside edge. So now I'm shooting from the center to the first edge. That's going to be the small r. And the small r is 36 minus 6 squared of x. What do you think about that? So like laser idea is also pretty cool because it goes through. The first time it goes through to the very, very edge. The second time it doesn't go through, it hits the very first function. So sometimes people like it this way more. Finally, let's actually integrate. How do we integrate cases like this? Pi is factored out, 0, so it's pi r squared minus pi r squared, pi got outside. 36 minus x squared minus 36 minus 6 squared of x squared. How do you integrate this? Ideas, suggestions, questions? Yes. You should know this, to be honest. This is still calculus 1, actually, very end of calculus 1. Distribute. Use the, but we cannot just put 2 everywhere, if you remember that. When you do that, again, some panda is crying. Don't do that. The formula says you cannot just put 2's everywhere. You have to use the formula a plus minus b squared, square of sum or square of difference. Square the first term plus minus, double product, plus square the second one. So minus happens if you have minus. So in this case, we do have minus. This is the formula. We use it quite a lot everywhere, so just memorize it once and be happy with that. You're not gonna make a box? Come on. Nice. So we're going to have pi integral 0, 36, 36 squared minus twice 36, that is 72x, plus x squared, that's the first term, minus, open parenthesis, 36 squared. You see how smart I did not calculate 36 squared? It will cancel out anyways. Minus 72 times 6 squared of x, plus square of 6 squared of x, dx, blah, 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 cancel out. Something cancels out. If you're careful with all the notation, something adds up together. Collect the terms, integrate, plug 0 and 36, and you will get a finite answer. Finish by yourself. We call it homework exercise. Finish by yourself. I don't want to spoiler this. So the other way to check yourself is actually integrate it in any computer program, which is, for example, Wolfram Alpha, and we can find out from there. But if you finish right now, let me know, and I'll put your answer in the video. So if you finish, let me know. This was the case. This was your homework number 12, by the way, for our class at least. So now you know how to do number 12. Let's see. One more example with a washer, I think is needed, so you clearly can see how we perform this weird idea of having gap inside. This was good. I actually do have, no, I don't have an answer. One more is this one. Washer. Y equals dx, still dx. I don't have dy cases. Oh, that's kind of sad, but okay. Example 2 for the washer. Let's quickly just skip the mass. Find the volume of solid obtained by rotation, the region bounded by. Okay. Bounded by. Just remember we're dealing with volumes now. One of the hints that we're dealing with volumes is rotation about some kind of function. Y equals 1 over x cubed. Y equals to 0. X equals to 3. X equals to 9. This will be area bounded by. That's your previous chapter, 7.1. But the moment we put about what, that makes it not the area anymore. So about y equals minus 4. That's the volume. So find the volume. Immediately I recognize that if I'm rotating about y equals minus 4, I make a note. It's parallel to what? Which axis? Y-axis or x-axis? X-axis. It's always the opposite, exactly. And you can always imagine it is horizontal. So we know it's going to be dx case if it is a washer or shell. So dx, but only for, not washer or shell, disk / washer. Washer is a ring. That's the one. So disk is when it's filled in. We did lots of examples on that. And now we do washers. Step 1, sketch the graph. So I have some cool stuff to show you later. Let's move it away. Sketch the graph. If you don't know how to sketch graphs by yourself, use graphing calculator or any other tool. 1 over x cubed. It looks like 1 over x squared, just faster. Whatever used to be squared, now it's cubed. So it actually approaches the vertical asymptote faster, which is this one, like so. Y over x cubed. Let's sign it. Y equals 1 over x cubed. Y equals 0. That sounds like a floor. So that's x axis. X axis, that's the floor. X equals 3 and x equals 9. Those are two walls. What kind of walls? Horizontal, no, vertical walls. X equals 3 and x equals 9. Do you see the area? Here it is. This is the area. And now I can spin it any way it can happen. I can spin it about this one. I can spin it about this one. And like in this picture I'm showing, why not to spin it with some kind of angle? We can spin it with the angle. So axis of rotation can be anything you want. It just makes it more complicated. And sometimes we do honor projects when we spin it around some other line tilted. Guess how do you deal with the cases when there's x and y, but we're spinning about something like y equals x? How will you deal with that, with the angle? Can you guess? Any guesses? Try to guess. So if we're not having it vertically or not having it horizontally, so it's not case 1 and not case 2, we have it tilted. How would you guess to deal with a situation like this? Engineers are supposed to have good imaginations. Don't you guys have like visual ideas? That's an interesting idea. Sine and cosine of 45. What did you want to say? Who will separate? Interesting idea. Divide it by halves and then find half and multiply by 2. We sometimes do that. Not in this chapter though. In this chapter we consider the whole rotation. More ideas? What do you think? Just imagine what would you do with a tilted cup? Why not to rotate it? Why not to rotate it and put this to be, for example, x-axis, my new x-axis, and this to be my new y-axis? Then you just need to know, rotate by what angle, and this is where you was correct. We're performing a shift of the angle, and it's trigonometric function step in, so you was right. Sine, cosine will be here. We need to know what sine of what angle, if it's random or it's 45, like you said. In general, renaming axes is a very classical thing in physics and engineering. Very classical thing. Something was shifted, be creative. Take that thing and shift it. To perform the shift, you need to know the angle, but then everything looks amazing, vertical, horizontal. So that's very classical idea. This one, though, says we need to revolve it about y equals minus 4. I do definitely know that y equals minus 4 is located below what I just draw. Here it is. Y equals minus 4 is my axis of rotation. Now, how to draw the picture? Imagine it's a mirror. Remember, that's what I keep saying. Recreate. So I have this gap. You have to recreate the gap. Then there is a line. One line up, tilted, completed. Agree? So that's how more or less I see it. And now I don't see it's a 3D object, so I'm gonna add. I will add a circle here, circle around, circle here, circle around. How about now? Now I see it's a 3D object. It's some kind of tube. Like so. And this tube has a small circle inside, which is literally a cylinder, empty cylinder inside. So it is a volcano lying down with the empty piece inside, right? It's kind of interesting. Maybe trombone, if you think about it. And now we just need to, it's not that simple, but now at least we know the picture. Here's the axis of rotation. I will put a notation that we rotated here. Do you agree that this is a 3D object with a hollow piece inside? It's empty inside. So step 1, 2D picture. Step 2, 3D picture. Step 3, choose the case. Now it's not just the case dx and dy, it's also what is the method we're using. Method, we don't use disks here because it's hollow inside. So we're using a washer. A washer. Because it's empty inside. Empty inside. Or has a hollow piece inside. Or it's not solid. You choose English how to explain. Does that make sense? What do you think? So you need to choose the case. From the case, formula matters. What also is the case? So let's do it. 3a. dx or dy? What did we agree? If it's rotating parallel to x-axis, it's dx case. So we're choosing the method, and when we're choosing the case, dx. From here, step number 4 follows, which is the most important, is your formula. Formula, if it's disk, it's pi r squared. If it's washer, it's pi r squared minus pi r squared. Integral from a to b, pi r squared minus pi r squared dx. That's what the formula is, since we're rotating about x-axis. Too fast or not? Ask me, what do you think about that? Not too bad. People are sleeping, don't sleep. Someone like smiled. Why she's looking at me? I'm not sleeping. Okay. V equals, kick pi outside, from a to b, since we agreed on the case dx. Now we know that it's going to be a physical location of the object from left to right. Do we know those numbers? Exactly. It's this cut we had. Thank you. The cut happened at x equals 3, and the cut happened at x equals 9. By the cut, I mean this object could be infinite, or it has like hundreds of square feet, but instead we cut it from 3 to 9. So now we know how wide it is. So that was simple. That's nice to have something simple. 3 to 9. And now we will have r squared minus r squared, and each will be top minus bottom, and then top minus bottom. Let's see if my strategy from the previous example still works or not. The first one is a field in R, capital R. The radius for the object doesn't have gaps inside. So whatever the disk method used to be. Why do we call it ring method again? Let me remind you just in case. If I do a sample slice, it will be a disk first. Disk has no gaps. But then you recognize that there is a hole inside. So we're using a donut. When we slice it, we see a donut. Or I call it a ring, or we call it a washer. Too many English terminologies, but the idea is clear. It's a donut inside. It has a hole. And that's why we're not calling it disk anymore. So here's my strategy. Let's check if it works, because maybe I was teaching you something wrong. Like, let's make sure we all approve it. That's very important for me, that people approve what I say when I teach. So put your dot in the axis of rotation in the center. Now it's a laser. Shoot your laser up or down, depending on which function you know. I don't know the bottom functions, like I don't know what the heck is this. Too complicated. I could create equations, but I don't want to. We know how to actually find symmetry of the function from pre-calculus class. Too complicated. Shoot the laser. I will choose to shoot up to the very edge. Now, this is the one. This is the radius that will recreate or represent the object with no gaps. Capital R. Top minus the bottom, because it's dx case. Top minus the bottom. That's it. Not too bad. What is the formula is going to be for top minus the bottom? 1 over x squared minus? Nope. Minus 4, exactly. Good job. 0 is over here. We shift it below 0 and rotate it there. And that's why signing all those lines is important. See, even with signing, my graph looks kind of confusing. So if you don't sign anything, you might lose all the information. Try to sign with different colors if you want, or pencils. 1 over x squared minus negative 4. 1 over x cubed, not squared, minus negative 4. Make sure you put parentheses, that's important. Y equals, that's the function at the top, y equals, as the function the bottom, which is -4. If you don't put parentheses, the formula will be wrong, because it's actually +4 at some point. That is R for radius for the field object. Now, only the empty part, not all things together. The empty part has small r. Let's go back, use blue color this time. Again, put a dot in the middle. Shoot the laser up, in this case. And then don't go above, shoot to the very first wall. So I shoot before to this last wall, now I'm shooting to the first wall. And do exactly the same thing, top minus the bottom. Now who is at the top? What is that? Y equals 0, exactly. Y equals 0 is now at the top. And the bottom is the same. Y equals -4. So it's going to be 0 minus 4. Agree or not? Does my logic make sense to you? Ask me right now, especially if you blinked and then, or your pencil fell on the floor and while you was picking up, now you see this madness. It's a very good moment to ask. You should always feel free to ask. What if you just zoned out for a second? What do you think? And now we actually simplify. No questions? That's suspicious. It's either very clear or very not clear. It's like there's never something in the middle. Why I'm simplifying? Maybe figure out some good question. So, again, the formula is going to be, let me write nicely, 1 over x cubed plus 4 squared minus squared minus minus 4 gives you just 4 squared dx. Simplifying the first one. By simplifying, we're going to use the formula square of sum. 1 over, is it cube, right? Yeah. 1 over cube, everything squared. So it's going to be x to the 6 at the denominator plus double product of 1 over x cubed and 4 plus 16 minus 16. That's nice. 16 cancels out. Dx. Blah, blah, blah. Simplify, integrate. I don't want to spend time on this. It's 1 over x squared. So integrate x to the -5 over -5 plus 8, x to the -2 over -2, multiply by pi. Plug 9, plug 3, and you get the answer. Approximately, it's pi multiplied by 0.396. And then since it's a volume, we kind of want to know what it is. So if you want to approximate involving pi, that's mostly for engineer and physics major. I was told to keep showing you guys what this physical object means. This is the approximate answer. I like this answer more because it involves pi. Units what? Cubed. So this object has a volume 1.2437 whatever gallons or whatever you feel it should be. Yes? Yeah. I kicked it out because it's pi r squared minus pi r squared. Yeah, thank you. That was a good question. More questions, ideas?